So if I combine. Okay, same. Right. Okay, so what we're looking at now are histograms. Yeah. So for histograms, the biology students have seen biology histograms. So let me show you exactly what. Guys, please, Dana soon. Come on, Dana soon. Listening? Yes. Yeah. So we start off first with our frequency table of data. So let's say here we have X, and here we have F. And let's just make it 5. And let's say this data here is mobile phone usage. So how many gigabytes per month downloaded on your phone, something like this. So this would be in gigabytes. So the first one would be, we'll go light users, maybe 0 to 1, and then 2 to 3 gigabytes, 4 to maybe we should jump it up a bit. They don't all have to be the same width, so maybe I'll go up to 6 here, and then we'll do 7 to 10, and then we'll do I don't know, 11 to 15, something like this. And these are all in gigabytes, so the unit here is gigabytes. And let's say there are 3 people here, 4 people here, 15?
That's the average, I assume.
10 it is. 10. What will we put here then, since you're so confident?
3. No, that's 3. That's it, 3.
And here? 1. Fine. So this is our data here for phone usage per month in a classroom.
Pretty accurate.
You feel? Oh, okay. That's more than I would have guessed. I thought most phone packages limit you at about 2 gigabytes a month, no?
7.5 or 17.
217?
Meter.
For how much a month?
I think 30.
Okay. 30, that explains why. And what do they charge you for 7.5? 20?
20, yeah.
I pay 20 euros for 10 gigabytes per month.
But they give you like
it's okay.
3 calls per day.
Yeah.
You can get the limit.
No, we see they say unlimited, and then they would say
10.
No, you
10.
you can get the full unlimited.
No, it's never truly unlimited. Like I just bought unlimited broadband this week, and I know it's not unlimited, so I checked the small print, and they say subject to fair usage, maximum 300 gigabytes per month. So it's never unlimited. The first thing you need to know about broadband in Ireland is never unlimited. Never.
In the UAE, they
Really?
No.
Yeah, but they say unlimited, but then when you read the small print, it would say fair usage maximum. It is cheating, yes. You're right, it is cheating.
That's right.
You're right.
At least it's better than the UAE. They charge you 20 euros for 1 gigabyte.
Internet
For 1 month.
For some reason.
That sucks, man.
I know.
That sucks. Anyway, back to this now. So here we have our realistic mobile phone data, and we want to put it into a histogram. So the first thing we need to do is calculate the boundaries. So nobody can use less than 0 per month, so we'll say 0 here. And here is 1.5, here is 3.5, here is 6.5, and here is 10.5 gigabytes. Okay. So, what's wrong? Oh yeah, the last one here, 15.5. Now, a histogram looks like a bar chart, but it's not quite a bar chart. It just has the same appearance. We're going to be drawing bars. So we want to work out the height of each bar. So there's two things you need to do first before you can work out the height. And then I'll explain what the bars represent in a moment. The first thing you need to work out is the class width, how wide each bar is. So this bar here would be 1.5 wide. This one here would be 2 wide, 3 wide, 4 wide, and 5 wide.
What is the last one?
10.5 to 15.5. That's
4.
15.5 minus 10.5 is 5, isn't it? Yes. Yes, we're happy. Okay, these are the class widths. Then you work out what's called the density, or in other words, the height of the bars. I'll just call them H for height. Now the formula to work out the height of the bar is equal to the frequency divided by the width. So if I do here 3 over 1.5, so height, which equals frequency over width, which equals, so the first one is 3 over 1.5, so that's 2. 4 over 2, that's 2. This is 3.33, this is 0.75, and this is 0.2. So these represent the heights of the bars. So this is important information. And the other piece of information you'll need to know are these things here. Okay, we have, I need to scroll down a bit, yeah? Do you have this information? Yeah. Okay, so what's basically going to happen is that this will be used for the x-axis and this will be used for the y-axis. So if I scroll down, what's my smallest x value I have? And the biggest? Right, so I should go up to maybe about 16. So here is 0, 8, 16. Here would be 12. Here would be 4. So this would be 2. This would be 6. This would be 10. This would be 14. And then this here would be 1, 3. Or maybe we should do that in a different color. So this would be 1, 3, 5, 7, 9, 11, 13, 15. Okay. And then what about the y-axis? What do I go up to? The maximum height. Right, so I'd want to go up to like 4. 4, 2, 1, 3, and then in halves maybe 0.5, 1.5, 2.5, 3.5. Now, the first bar, the way these work is that this is the start and the end of the first bar, and then this is the start and the end of the second bar, the start and the end of the third bar, the fourth bar, and then the fifth bar. So the first bar goes from 0 to 1.5. So there's 0, and there's 1.5, just about there. And what's the first height? What is the first height, please? 2, is it? So that would be here. Okay. Then the next bar goes from 1.5 to What's the next value, please? What is it? It is 3.5, yeah. And what's the height? 2 again? The first two are 2? Alright. So the next one is to 2. Okay. What's the next bar is 3.5 to 6.5, and what's the height of that? Okay. And then 6.5 to 10.5, and its height? Okay, and then 10.5 to, yeah, and its height? Okay, and here this is a gigabyte usage, or usage in gigabytes, I should say. Per month. And then here, this isn't frequency now, despite what Colin told you in biology class. This is frequency density, or another way of writing is frequency per gigabyte, or frequency per X unit. So it's frequency per usage in gigabytes per month. So I'll just write frequency per unit to make it simple to write. Another meaning of this is density, which the physics students know what density is. It's mass per unit volume. So that's what this is like as well. Instead of mass per unit volume, it's frequency per unit gigabyte usage. Now you might say, why not just do what I did in biology and use the frequency? Well, this graph here is much more useful to you. What's wrong, Anthony? It's the second time I have to stop talking because I see you talking. What is the benefit here? Joshua, you said you just needed 5 minutes. What took you so long? What? Bus? You took... Just sit down. I'd walk faster because I've hit you now. Come on. So the advantage here of using this graph is as follows. By making your graph this way, if I just go to the side for a moment, how did you work out the height of this graph? What was it? It was frequency divided by width. And then here, this is width. So what would be the formula for area here? Frequency over width multiplied by width. This multiplied by this. But these cancel. And this is why the way I showed you is most useful, because now we have this result, that the area on the histogram represents the frequency. So by calculating the height this way, it means that the area of the bars represents the frequency. So if I just go back to the graph now, watch. How big is this base here? It is 1.5. What's 1.5 multiplied by 2? 3. So the area of this bar is 3. How many people, how many people use between 0 and 1.5 gigabytes? 3. It's 3 people. Now let's look at the next one. This is 1.5 to 3.5, so that's 2 units, isn't it? 2 multiplied 2, what's the area? It's 4. See? 4. This area will be 10. this area will be 3 and this area will be 1. So here, histograms are useful to us because the area equals the frequency. This is why histograms are useful. So let me give you a demonstration of what you can do now with the histogram that you couldn't do with just a table. I need to remove those numbers 3, 4, 10, 3, 1. Okay, I removed this. So I'll give you a realistic example, okay? 13, 19, 20. There's about 23 people here, something like this. So, you know, roughly the same size as this class. So you can imagine I gave people a questionnaire and I asked them how much usage do they use on their mobile phone per month. So the answers are your 0 to 1 gigabytes, that's 3 people said that, 2 to 3 gigabytes, 4 people said that, 4 to 6 gigabytes, 10 people said that, and so on. So if I ask you, how many people used 7 to 10 gigabytes? How many people was that? It was 3. Yeah. How many people use 7 to 10? 3. But now suppose I asked you how many people use between 5 and 8 gigabytes. Can you see that on the table? No, you can't. It's impossible to see it on the table. How many people use between 5 and 8 was not one of my answers. But you can estimate that from the histogram. What you do is, you go to 5, which would be here. You go to 8, which would be here. And we know that the area represents the frequency. So if you got the area of this shape, you would have the answer. So we need the area of this piece and the area of this piece. What is this? This is 6.5, isn't it? And this is 5. So how big is this base? 1.5. And what's the height of this rectangle? 3. Plus 6.5 to 8 is 1.5, isn't it? No? 6.5 to 8 is how much? Yes, thank you, Joshua. 1.5, and what's the height of this rectangle? 0.75. So that would equal 1.5 times 3.7. What's that, please, on the calculators? What is it? 5.625. So you have 5.625 people use between 5 and 8 gigabytes per month. Now you might say that doesn't make too much sense because you can't have 5.625 people in this class. But what you could do is convert it into a percentage of the class. How many people did I say were in the class in total? 23, was it? We just double check that. In this one it is 14 and 21, sorry. So if you just put this as a percentage, I'm curious what it would be. What's that number, please? It's about 26% or so.
26.78.
What is it?
26.78.
26.8%. So look at what you were able to do now with the histogram. Although you didn't ask people, or you didn't give people the option of picking 5 to 8 gigabytes, I could estimate that 26.8% of students use between 5 and 8 gigabytes. Even though I don't have that information in the table, I can estimate it from the histogram. The height? Yeah, you see, this is what happens when you come in late. In the exam, the structure of the section B question is very similar each year. First they ask for the mean, then they ask for the standard deviation, then they ask for a graph. If they ask for a cumulative frequency, then you draw the cumulative frequency, and histogram, you draw the histogram. But then the next part of the question is you must use your graph to calculate something. So, for the cumulative frequency, what things can you get from your graph? What are they? The lower quartile, the upper quartile, the median, and the interquartile range. From the histogram, we can calculate the frequency when it's not present in the table, and there is something else useful we can get from the histogram. The mode is the most frequent. So in this case, the histogram, we can find the mode by looking at what's the biggest bar. Oh, you will need the frequency. Ah, well, like what I just did, the 5 to 8 bracket is not present in the table.
Oh, that's the one.
Yeah. So which bar is the biggest here? This bar here, isn't it?
46.
Yeah, so we have to return just one number as the answer. So we usually go with the middle of the bar. So what is it? The middle of the bar would be, this is 2.5 and this is 6.5. So 2.5 plus 6.5. Oh, sorry. 3.5, is it? To 6.5 divided by 2. That's 5, is it?
Yes.
So here the mode would be 5. We estimate the mode to be 5. You look at which bar is the biggest. Can you see which is the biggest? Of course you can. This bar here. But we do not return our answer as 3.5 to 6.5. Instead, we usually give the answer as the mid value. So the middle of the bar. So the middle of the bar here is 5. It's the middle of 3.5 and 6.5. Yes, Joshua?
So what do you call when you make an X inside the bar? I'll show you the bar.
When you make an X inside the bar?
Yeah, like you intersect and the point of intersection.
What?
Square?
Point of intersection? What are you talking about? I didn't do any point of intersection. Go on.
I'm just asking
Yeah.
you make an X inside the rectangle and you trace the point to intersect to the X axis.
I haven't done that. But you have done that, is that what you're saying?
Yeah, what do you want to do?
To me, that if you put an X inside the bar and then go straight down, is it? That's just the midpoint of the bar. Which is the same thing as what I'm doing here. So the name of that would be midpoint estimate. I've never seen anyone do this though, but I'll take your word for it, okay, that you've done it before. If you have a look at the question, please. In number 1, I give you the lower and the upper boundary. Number 2, I give you the lower and the upper. Number 3, I try to complicate your life a little bit by not giving you the frequency, but instead I give you the cumulative frequency. So how many, whatever it is, would be between 0 and 394 centimeters? How many is that? 1. How many are between 394 and 419? 1.
Who said 1? 1.
I said 1. Think about this. No, guys, you need to be listening, please. Imagine these lengths in number 3 are the heights of a tree. How many trees are smaller than 394 centimeters? 1. Joshua, I'll do this again. How many trees are smaller than 394 centimeters? 1. How many trees are smaller than 419 centimeters. 2 plus 1.
Yes,
No, 2, just 2. I tell you right here, there are 2 trees smaller than 419.
The one before that. Oh.
It's been already included. Because if you look at what I wrote, I didn't write 319 to 419. I already wrote 419. This is already a cumulative frequency table.
okay.
How many trees are less than 444 centimeters? Right, no. Therefore, how many trees are bigger than 394 but smaller than 419? 1. Do you see why it's 1? Because I said going from 394 and 419, I've gone from 1 to 2. So I've included 1 extra tree. That 1 extra tree must be bigger than 394 because it's not included there, but it must be bigger than 394 because it's included in the 419. How many are between 419 and 444? 1. Between 444 and 469? 7. So I'm just making you work backwards from the cumulative frequency to the frequency. Why? Because I couldn't imagine how else to make these questions different. Okay? Sorry. I mean, it's really just here's data, draw a graph, so I have to change them a little bit somehow.
They ran out of imagination.
Yeah, well, there's not much you can do with these.
How do we get the midpoint or the
So once you have the frequency table reconstructed, the midpoint would be the lower plus the upper divided by 2. You see, Joshua, for this one here, you have to go completely backwards. You have to go from cumulative frequency back to frequency table.
So kind of the 0 to 394.
Yes, that's fine, because I was talking about length can't be negative, so yes, it'd be suitable to start at 0 here.
And then would it, the one after would be 395 to 419?
Yeah, I would say 0 to 394, not including 394, and then 394 including 394 to 419, not including 419. Then 419 included to 444, not included. Remember, the lower boundary you include and the upper boundary is open. You don't include it. So for me, it'd be 0 to 394, then 394 to 419, 419 to 444, 444 to 469, etc. Yep. About the histogram, again, a couple of mistakes people make. So what's mistake number 1 that could be made here? Do you think? Yep, stupidity is a mistake. Give me an example of stupidity, please.
I can't lower myself to that.
Alright, fine, that's fine. You don't have to answer that. Yep. What's that? Using frequency instead of frequency density, otherwise known as the column known mistake. Yep, that's fine. What other possibilities are there here? Swap X and Y would be a good one as well. But that would be you, isn't it? Alright, fine. What else would be a problem here on the x-axis? Yeah, instead of using lower and upper, they would use 0 to 1 and 2 to 3. If you use 0 to 1 and then 2 to 3, there'd be a problem with your histogram. The bars would not be touching, and this is very bad. For a histogram, the bars must always touch. So if you use 0 to 1 and then 2 to 3, your graph would go 0 to 1, you draw your bar, and then you skip and go 2 to 3 and draw the bar. So your histogram bars must touch. They must be beside each other. So when you're looking at your histogram, there are 2 things which you should expect from your histogram that will make you feel like you've done it right. Firstly, the bars must touch. There must be no gap between the bars. That's the first thing. And the second thing, usually, not always, but usually the histogram has a bell shape to it. It goes up and then it goes back down. Now this is not a rule. It doesn't always go like this, it just normally goes like this. In the previous graph, the cumulative frequency must increase. That is a rule. Whereas here I'm saying it's not a rule, it's just usual that the histogram has a kind of a hill shape to it. Again, not always the case. I think when you look at your pollen data in biology, I believe the histogram has a kind of a double shape to it. It goes up and then it drops a little bit and goes up again and then it drops down. Yeah. We'll look at the vocabulary for describing the different shapes of histograms in the last lesson, okay? But 90% of the time it's just a hill shape. Yeah, bell curve, yeah. Or a normal distribution as well. Okay. Anything else to say about it? Oh yeah, I know I'm teasing Colin about putting the frequency on the y-axis, but if you look at different statistics books, some statistics books use frequency and some use what I've just done, the density. The density I always use because that is what they use in the exam when they've asked this question twice. And then also it's more useful because if I use this I can make calculations. It's not wrong to use frequency, it's just not useful. Okay? But you might see frequency being used in some books. I would consider this much more useful to be doing. Like in my example about calculating values like 5 to 8 gigabytes. That's something I couldn't do with the table. But it is something I can do with this histogram. Okay. So again, you want to draw this on graph paper really, really neatly, and it should be full marks. I'll let you try these for about 5 minutes or so. Okay, so in number 1, I already give you the upper and lower boundaries, so it shouldn't be too difficult. Okay, try these for a few minutes.